Good morning everybody, welcome to the first Year 8 lesson, video lesson that is, on geometric sequences. It's Mr. Ball speaking if you haven't recognised my voice yet. So what we're going to have a look at today is geometric sequences, building on the work you've previously done in the chapter. Yesterday you guys were looking at sequences in context, that was 13b, so yesterday, whatever the last lesson, whenever you did it. And that was particularly concerned with something which we call linear, or another word for it which you may come across, especially if you do A-level in the future, which I hope you do, arithmetic sequences. So a linear or an arithmetic sequence, the ones you did yesterday, they're the ones where to get from term to term, all you need to do is add or take something away. So for example, 3, 8, 13, 18, that's a linear or arithmetic sequence because to get from one term to the next I just have to keep adding 5. So the last lesson was all about adding and taking away. Today what we want to look at instead is a geometric sequence. And geometric sequences aren't to do with adding or taking away, they're to do with timesing by something instead. You could look at it as a dividing, but we're going to try and focus on it as a times instead. So geometric sequences. So in these ones with a term-to-term rule, you need to multiply by a constant. So for instance that constant might be 3, or that constant might be 5, whatever it might be. So for instance if I wanted to do this, let's just pick one at random, let's go for 2 is my first term, and let's say my constant difference is 3. So if I times 2 by 3 I get 6. If I times it by 3 again, I get 18. If I times it by 3 again, I get a lot more, 54. If I times it by 3 again, I get 162. And I hope my 3 times table is just about held up there. Looks like it has to me. So just to reiterate this point, linear or arithmetic ones, you are adding something every time, adding 5, adding 5, adding 5. For geometric ones, you are timesing by something every time. Now, you could times by a fraction, and that would be similar to dividing. We'll look at some of those later, but just try and get that in your minds in the first instance. Linear or arithmetic sequences, you're adding something every time. Geometric ones, you're timesing by something every time. So, let's have a look at an example of this, and then you guys can do some of the questions out of the book and see how you're getting on. So here's an example, it's the example which is in your book, but let's go through this together. So it says generate the first 5 terms of the sequence following this rule. It says start with 6, so 6 is the first term, and then multiply each term by 4 to get to the next one. So can you guys just have a quick think about what those first few terms are? Just pause the video for a second and then come back to me when you've had to think about that. So hopefully for the first one you wrote down, or you thought to write down, my first term is 6, and to go from one term to the next I need to multiply by 4. 4 times 6 is 24. 4 times 24 is 96. 4 times 96 is, oh crikey, 360 plus 4 times 6, which is going to be 384. I hope that's right. How many does it want me to do? The first 5 terms, of course it does. And then 4 times 384 is whatever it is. I need to actually work that one out. It's 1200. Plus 3 times 80. 3 times 80 is 240. And 3 times 4 is 16. So I'm hoping, and hopefully someone can check that for me on a calculator, the last one there is going to be 1, 4, 5, 6. Which isn't right because, no it isn't right because that should be 320. Let's try again quickly, sorry for this. So 4 times 300 was 1200, 4 times 80 is 320, 4 times 6 is 16, 6, 3, 5, 1. That smells a lot better. Yes, that's much better. Good. Okay, so let's just get rid of that 1536. Okay, so that'll be the first 5 terms. Assuming I got this term right, I think I did. And for part B, it says describe a term-to-term rule for this geometric progression. So it gives you a different geometric progression. It gives you 5, 15, 45, 135, 405. So have a quick think or write it down in your book. What would you write down as the rule for 5, 15, 45, 135, 405? Pause the video and just have a think about that or write it down. So the most common mistake people make here, well, let's just do the first bit first, and then we'll talk about the most common mistake. So if I wrote it out, I've got 5, 15, 45, 135, and then 405. So I think a lot of you would have just looked at these first two and said, okay, that's going to be times by 3. However, if it wasn't particularly obvious what to do, you can take this here, so any term, and if you divide it by the previous term, it will tell you what you need to times by. So sometimes it isn't obvious. In this case, it was really obvious. I think it's times by 3. If it's not obvious, pick any term, divide it by the previous term, and it will tell you what that common ratio is, what you need to keep timesing by each time. So I can imagine lots of people said the rule is timesing by 3. And hopefully some of you are shouting at your screen now and saying, no, you need to have something else, Mr. Ball. And of course you do, because if the rule is just timesing by 3, well, that could be 1, 3, 9, 27, or it could be 6, 18, 54, or it could be 4, 12, whatever 3 times 12 is, 36, there we go, 108. You need to state what the first term is. So the rule is times by 3, and we need to say first term is 5. Okay, so it's important you have both of those pieces of information there. Times by 3, first term is 5. And part C, 2 parts here. Write the next 2 terms of this sequence. So think about what the term rule is. It goes 200, 100, 50, 25, 12.5. So hopefully you'll look at this and say, okay, it's halving every time, so I need to halve it again, so that's going to be 6.25. If I halve it one less time, it's going to be 3.125. That's part 1. And it says describe a term-to-term rule for the sequence. So have a quick go at that, please. So hopefully you've said that the rule is, well, we're halving every time, and halving is the same as timesing by a half. Okay, because I want a half of 200 to get 100. I want a half of 100 to get 50. So the rule is timesing by a half. Remember, of means timesing when we're thinking about mathematics. So rule is times a half, first term is equal to 200. Okay, so I hope that example has given you a flavour of how geometric sequences works and has made you think about how to find the rule, how to write the rule down, how to find some next terms. So what I'd like you guys to do is spend a little bit of time now looking at exercise 13C, question 1 to 4. If you can spend, well, we're about 9 minutes into the video so far, so if you guys can spend about 20 minutes looking at that, check your answers as you go. Do not do loads of questions in a row and then check your answers afterwards, because if you got one wrong, you may have loads wrong and you may have been doing it wrong all the time. So do a couple, check your answer, do a couple, check your answers, make sure you're getting these right. After you've done that, come back to the video and we'll look at the last example on that page, and then you guys, if you've got some time left, can do question 5 to 7. Okay, so pause the video now, have a go at some questions, then come back to the video, please. Okay, I hope that's all gone well. If it hasn't gone okay, then just contact your teacher, email your teacher, and hopefully they'll be able to give you some help with that. Can I just please stress that you need to contact your class teacher about these questions. If you all contact me, then I've suddenly got 250 kids to deal with possibly at the same time, and I've already got nearly the best part of 100 Year 12s to deal with. So please email your own class teacher, at least if you want a speedy reply. So this question is really good. It's geometric sequences in real life. We're sort of seeing a geometric sequence at the moment. It's not quite a geometric sequence what we're seeing in terms of the pandemic that's currently happening, but it's got a sort of similar flavour to it. The idea that things are increasing by more and more each time. Obviously now we're on a downward trend, which is a good thing. But in the early days of the pandemic, it wasn't going up by 10 people a day. It was going up by 10 and 100 and 1,000. It was something we know now as exponential growth. But this is quite a good one, the one about the birds of prey here. If you introduce a population into a region, they might, if they take off really well, sorry for the pun, their population will probably increase quite quickly in the first few years. However, due to their surroundings, such as the amount of food they may have, or maybe starting to move into other areas where they might have predators of their own, such as us, for instance, they won't carry on with that huge burst of population. So this is quite a nice example where we've got a bit geometric sequence at the start, and then it merges into an arithmetic sequence for a few terms. So let's have a look at the question together. Geometric sequences occur in real life. Yes, we've just talked about that. 50 birds of prey are introduced to a region of the country. The population doubles each year for 5 years and then increases at a steady rate of 100 birds per year for the next 5 years. So before we do anything, let's just make sure we take on board what that says. It says it doubles every year for 5 years. If it doubles, that must mean it's timesing by 2 every year. So for the first 5 years, it's a geometric progression, or geometric sequence. It then increases at a steady rate of 100 birds per year for the next 5 years. So if it's going up by a constant amount every year, then it's suddenly turned to a linear or arithmetic sequence. How many birds are there after 10 years have elapsed? Okay, so what I'd like you guys to do is think about this from the geometric point of view. So that's years 1 to 5. And then think about it from the linear arithmetic, whichever one you want to call it, for the years 6 to 10. So just have a quick go yourselves and then come back to the video after you've had a go. Try and think about what the population is going to be after those first 5 years and do that by writing each term out, and then try and do the linear bit and then think about if you've actually answered the question by writing those things out. So pause the video now, come back to me in a moment when you've done. Okay, so geometric wise, now some people get this bit a bit confused. 50 were introduced at the start. So that's sort of at year 0, because we haven't no time's elapsed yet. We've literally just plonked them in an environment. And then to get to the next term, I need to times by 2. So then I've got 100. So that's after year 1. Even though it's my second term, it's after year 1. Then I times again to get 200, 400, 800, and then 1600. And let's just write the numbers above just to make sure I've got this sure. It's year 0, year 1, year 2, year 3, year 4, year 5. Okay, that makes sense. And then after the 5th year, it turns to an arithmetic. So after year 6, I get 1700, and then 1800, 1900. I should really have commas in between these because sequences are a list. 2000, 6, 7, 8, 9, good, 10. Just write those numbers above just to doubly make sure I've got the right amount of years I have. That's good news. Okay, so there's my 2 sequences. I've thought about the geometric bit, I've thought about the linear bit, and it says, the last bit of the question, it's really important that when you've done your maths, you look back at the question and say to yourself, have I actually answered it? It says how many birds after 10 years elapsed. Okay, so I've written this all out, and I just need to make sure that I just write this down somewhere. It's a question which is in context, so I need to give an answer which is back in context. So I can use a connector which is therefore. 3 dots means therefore. Therefore, there are 2,100 birds after 10 years. And I know you might be saying to yourself, well, it's really obvious from what I did up here that it was that after 10 years. But if the question is a worded question with context, you must give some context in your final answer to get that last mark. It's a communication mark in your GCSE, which you'll miss out on if you don't just write that sentence at the bottom. So what I'd like you guys to do is have a quick go at the last few exercises from here. You've had about best part of 20 minutes, I suppose, in terms of video. You should have done about 20 minutes of practice earlier. So if we say another 15 minutes trying to work through these last 3 questions, then that would be fantastic. And if you want some help with the first question of this, I'm going to have a go at that quickly now. And I should have probably had a go at one of the earlier questions as well. But send that to your teacher if you're struggling with that. So I'll have a quick go at question 5. So if you're struggling with question 5, come back and check. Question 6 and 7, can you just check with the answers, please? So just pause the video now, have a go at these questions, unpause the video if you want to have a look at question 5 together. Okay, so question 5 is a nice question. You've got 2 options. The first, so option B, let's have a look at that one first. Cassie's offered this summer holiday job for 6 weeks, so she can have £50 a week for 6 weeks. So option B, it's really important that you try and set your working out in such a way that people can see what you're doing. So I've written a B here because I'm talking about option B. She could get 6 times £50 from option B, which gives her £300 altogether. Then I can have a look at option A. Okay, so option A, it goes 5, 10, 20. Let's write those out. 5, 10, 20. Now, let's just pretend I don't recognise certain times tables for a sec. If I want to know what the common ratio is, I can pick any number in the sequence, so let's pick 20, and then divide it by the previous term. If I divide 20 by 10, I get 2, so the common ratio must be timesing by 2 every time. Times by 2, times by 2. So it goes 5, 10, 20, 40. How many weeks do I need to do? 6, don't I? 80, and then 160. So, this is a common mistake that people might make. They might now say, okay, we'll definitely pick option B because she gets £300, whereas option A she gets 160. But that's not right. That's just how much she gets for week 6. So to find the total for option A, you need to add them all together. So we've got 5 plus 10 plus 20, plus 40 plus 80 plus 160. And if you add all those together, you should get 240, 280, 300, 315. So, we're probably finished. But hang on, let's just read the question again. It says, which option should Cassie choose? Give your reasons. So we've done all the maths, but now we need to do that communication mark again. So, Cassie should choose option A. Choose option A because she'll earn £15 more. And as simple as that. Okay, so if you have any questions about question 6 or 7, please can you email your teachers about those. I hope this video was useful, and I will speak to you again in another video very soon. Have a great day, and I'll speak to you again soon. Bye bye.